My name is Daniel. I'm from MapleSoft. I'm going to fill this time with doing a little bit of a demo for you. I was told I was filling in for this spot just 2 days ago, so I did rush a couple of examples in based on kind of some of the talks I've already heard. But I did kind of feel like there's some important stuff to talk about. And actually, Doug's example at the end of his talk was very well timed because it's going to allow me to transition really well into this talk. Specifically because I think what Doug showed in his last couple examples there, we're talking about DEs, was a couple of examples of interfaces, or kind of Maple documents where there was buttons and sliders and dials and gauges and all types of things that people were interacting with. And we call this interactive content, or you call it interactive documents or math apps, or you can call it any name you really like inside of Maple. But I think if you ask my opinion, it's really something that is an important part of Maple's evolution. You know, we've seen Maple from its command line days from the start, you know, evolve and you know, you start with character plots and then you go into, you know, you finally got 2D plots, 3D plots, animations, things like that. And I think today what we have with interactive documents and some of the stuff I'm going to show you today is as pivotal and as important as can be when it comes to using Maple. So, and I think the reason for that, the reason I'm motivating that is what Doug was talking about was student understanding. You know, putting documents in their students' hands and having them use Maple for more than just a simple calculation, right? It's no longer just about, you know, doing solve and getting back some solution. It's actually about using the interface to have some type of kind of cognitive dissonance. So there's some conceptual understanding that you actually get from using a Maple document. So with that precursor, let me jump in. I'm going to deconstruct a little bit of what Doug was talking about in his argument. And I'm just going to talk about making documents interactive. I'll try not to move around as much for the camera as well. So making documents interactive, what I mean by that is simply that we can take a Maple document, we can have some controls. So here we have a simple example. There's amplitude, there's phase shift. So what we have here is a system. It's a simple system. We've got two parameters. They're reflected right here as well as right here. And as a user, you know, you open up this document and you have controls. So I'd like to call these as inputs, you know, if we're just starting off with some terminology. So these are inputs. The first one is our phase shift. It's controlling this term. Amplitude is controlling this term right here. Now, when we're playing with these, we're actually seeing the function changing, we're seeing the derivative changing, and we're seeing the plot of the tube changing as well. So from a usability perspective, it's very simple, right? We're not talking about writing plot 3D or plots animated or anything like that. We're just talking about using a dial. So I start with this because it's an important idea. What we have is we have input controls for two parameters. We have outputs for the function, its derivative, and a plot. So in Maple, we saw these debut last night. We have a whole bunch of embedded components. And these are all things you can put into a Maple document that let you take control in some way. And there's a mixture here. We've got buttons, checkboxes, combo boxes. There's stuff here that's for input. And that would include things like math containers or text areas, and even plots. But there's also a lot here that's for output. So the output would be the math container, the text area, the plot. So it's ways for somebody to come in, a student, a peer, whatever you may have, to go into your document, open it up, and have some level of control over whatever's happening in your document. So there's a whole bunch of different ones here. I'm going to play with a couple different ones during this session today. And but I want to show you kind of the stuff, the highlights from our own collection of interactive documents. So Doug's examples were perfectly timed because they were examples of interactive documents. So there was a couple of sliders there. There were some text areas for putting numbers in to control the differential equation system and so on. So, you know, this is something that Doug and his students spent some time building. And we're no different. You know, we've spent time building a whole collection of math apps. So inside of Maple, if you go up here to Tools and Math Apps, you'll see our guide that we have for math apps. And typically when I'm telling people about this guide, what you see here is algebra and geometry, calculus. There's stats down at the bottom. You kind of see it mapping into courses more than anything else. And if I do go down this list here, we'll see algebra and geometry, and there's the whole calculus series as we get a little bit further down the list here. So here we have differential calculus, integral calculus, as well as vector calculus. So this is a collection of interactive documents. This is stuff that we spent time coding up. So I've got a student right now, I've got an intern from the University of Waterloo. She's spending her time making new linear algebra applications. This is kind of what we do, is we crack open textbooks and we're making new examples. That's probably the best part of my job. So I'll show you a few of these. We did look at these last night, I think, but and Doug's examples were bang on, so we won't go too far into them. Here's one for Riemann sums. Typically what we do with a math app is it's a Maple document. I'll leave this one open. And this is the nice part about using Maple document, is you can put text alongside of math. Here we have some more math that's typeset. So we go through, we give a little bit of a conceptual understanding of a problem. And we don't go too far into it because that's honestly the job of you guys in the classroom. You know, we just kind of do the basics. Where we focus is on the interactive stuff. And this is honestly, you know, it can be said that building applications can be done fairly simply in Maple, but I think this is, there's complexity here because taking an example and trying to get pedagogical value from this is not easy. So here we have an example for Riemann sums, and we can change the type down here. We can use a slider here to increase and decrease the number of rectangles. So this was pretty straightforward. This one is something you might actually draw on a board or work through in a classroom, right? So this one was pretty straightforward for us to work with, and kind of when we were working and coding this one up, it made sense. But it does take time. It takes time for us to build these because sometimes, you know, you have an idea, you have a concept you want to talk about, but just to kind of figure out the best way of showcasing it, using all this awesome technology we've got in Maple, that will take time.
Can you show us one? I mean, I would very much like to be able to do that.
Yep.
So
I can.
Okay.
Yeah,
cool. Absolutely.
Yeah. So I mean, right inside of Maple, we do have, there's 465, last time I counted, examples like this. Well, what I'm going to talk about in just a little bit is easier ways of making stuff like this. So I'll get there in a minute.
Okay.
All right. So this app here, the one that we've built here, to give you a preview, I won't go into the coding language today. This is actually all built using Maple code. If I click on this button up here, this is the Maple language being used to drive interactions. So we scroll down here and we can see a bunch of command calls and so on. And the purpose of this talk is not to talk about this stuff, but key commands here are things like document tools set property, document tools get property. It's a language we have for talking to our components. So we're able to query the state of things, we're able to retrieve that and use that in various ways. So I think last night we saw an example where we were trying to retrieve from a rotary gauge that value and show it on a plot. So we do a lot of this in the Maple command language. The nice part about working and creating apps in this way is that whatever we've done in this app, this is our best approximation of something that will cover this area. Everything that we do in this app is customizable. So if you go in and modify that code, here's our version of Riemann sums, but you can take this app and change it. So it doesn't need to be this color scheme. It doesn't need to have these values. You can modify anything that you see here. So I would say first and foremost, if you are getting started with creating content, I wouldn't even start. I wouldn't open up a Maple document. I would just go into our guide that we have for applications and see what we have. Just because we have so many. We have to keep our students busy. We have to keep them working on these examples, right? So for us, this is really essential work. So going in here, I'm going to show one more example because I always like showing this one in front of crowds. Volume of solids of revolution, volume by disks. So here we have controls for input. I said before that a plot can also be input as well as output. So here we have the ability to, on a graph, draw out a line. And on the right side, we're revolving that around an axis. So this is all things that are possible with using embedded components in your document. Now, under the hood of all this stuff, everything we're doing here, it is the Maple language. I clicked up there before, and I showed you kind of the code behind the scenes. But what we have here is we probably have a command coming from Calculus 1, our student package. And we're just taking that information over here, and we're just taking it here, and we're rotating that around an axis.
How do you look at the code behind? I mean, what do I press to see the
code behind these? So the code behind these, for these applications, it exists behind what we call startup code. So when I clicked up here, it's kind of filled in with this
I see it.
gray box there.
Okay.
That's the code, and that's,
Okay.
yeah, I won't go far into that today just because that's a whole lecture on its own. We put all the code into what we refer to as a startup code region. So this is code that loads at the time that you open up a Maple document. So it's a bunch of procedures, it can be modules, that we require for this application to run. So this is, the way we code these is in this way, because what you actually see is when you're actually doing something here, component, and edit drag, yeah, there we go. So this is actually calling Maple commands. So when you click on that plot, we're calling revolution, :end drag. So all your actions are being called from code that you're loading.
I see.
Yeah. So this is...
If I could just maybe answer it in a little different way. So every action, right, has, I mean, if it's a programmed action, whether it's a button click or a mouse move,
Yeah.
does something,
Yeah.
right? So in that command,
Yeah.
it does that. It calls that command that was there. The command is actually in the startup. It's like an initialization file.
Yeah.
So that you don't have to keep going. So you can, I mean, you could put all the code in the component, but then the code for each component it has to be connected, and it's just hard to do that.
Yeah. Yeah.
So this, I mean, you're just defining actions or responses to actions.
Yeah.
When you change that function, what does it do? When you hit that reset button, what does it do? When it hit the animate button, it calls a Maple procedure to run. And those procedures are all in the startup code.
Right.
Okay.
Yeah.
And that could affect multiple elements in the interface there.
Yeah. All right. In the interest of time, I'm going to move us on. I could spend the entire time talking about authoring apps using startup code and everything like that. And actually, I have recorded a whole bunch of videos there on our YouTube channel that do talk about this methodology. I will mention one more tangent to all this. We work a lot with schools. And a lot of the content that, say, Doug just showed, or the content I'm showing in the Math Apps Guide, is content we prepared for classes. But I'll show you this example here. This is a gas orifice flow meter calculator. A lot of our industrial partners, commercial customers, they sometimes use Maple, and they kind of use it in an app way. So you might go on site somewhere, and here's an example. We have a Maple table filled in with a bunch of text areas and a button that does something. So talking about Doug's example here, what we have is we have a number of variables, so pipe diameter, molecular weight, and so on. We're filling in those values, we press a button, and it returns a value to us. So some of our industrial partners, what they do is they use Maple as a calculator, but they don't use it just as 1 + 1 = 2. They use it for specific applications. And then they have maybe somebody who's a Maple coder, they have somebody who's doing this work for them. But then they have somebody else just down the line who's pressing buttons, changing values, and doing computations. So you can imagine this as well. So it's not just an application for academic markets. It's also something that is used in industrial and professional sites. It's something that takes Maple documents away from just being strictly a calculator and brings them into an industrial direct application for industry. So with that said, I wanted to leave it there because really the crux of what I wanted to talk about today, this was the precursor. The applications we have are great, and they form a really good content base for anybody who is looking to teach today. But the question always comes up, if I want to build my own stuff, what's the fastest way for me to do stuff like that? And I want to spend the rest of this time talking about Explore. And Explore did make a cameo last night during Laurent's talk. And the example that he gave was this one here, where we did a factor of a symbolic sum, values from 1 to n of x to various powers. So going back and using the terminology at the start, we have a couple of parameters in theory here. We have k, which is our parameter that we're going to be looking to change the value for. Technically, n could be looked at as a parameter, but we want to keep this symbolic. Maple's a symbolic language after all, so we don't want to mess around with n. So the example we saw last night was taking this factor of the symbolic sum, choosing explore, and using what we refer to as the explore assistant. So this assistant is a way for us to build something interactive. So leaving all these settings alone for now, these are all options within the explore command. What we can do is we can explore values of a parameterized system. And we'll skip n, we leave this as a symbolic endpoint, and we press explore. And this was the example we saw yesterday. So here we have the symbolic sum for the first n natural numbers squared. But what's different here is so what we have here is this is a slider. Here we have a math container. And what explore did is it builds the interactive stuff for you. So there's no extra coding. There's none of that other stuff here. What explore does is it builds an interactive thing. You can go over here to a new document. Copy it in here. And this is your application. You take that, you save it to the cloud, and you have something you can share with your students.
And can you see the value changed code? Is there anything to see for that?
There is, but there comes with strong disclaimers. Yeah. So what explore does is it writes its own code. Here, so we have explore runtime update. So this is one of those cases, modify at your own peril. So you can go in here, you can modify that, you can change it. You can actually use this to build apps. There's a video I recorded on YouTube about that as well. So you can use explore to build more complex apps. But realistically, what explore does is it kind of glues the input with the output. So we can have a couple of parameters, we can have a couple of controls that we hook up, and we make an interactive application. So as I said, I was told about this presentation just a couple days ago, so I didn't have enough time to really put together all the fun examples I wanted to, but based on the conversations around rooms, I had to put together one for pi. And I guess this is probably a question for the room, but I'm not really sure how many digits of pi we store. So this may or may not break as I go into more values, but if we do the evalf command in Maple, you do evalf of pi, you get back pi to 10 digits. And that's all interesting, but one of those questions that does come up every so often is, okay, show me the millionth digit of pi or the 100,000th digit of pi, what have you. So I was playing around last night. I was trying to come up with interesting ways of doing this, and I was chatting with Steve Forrest, who's up next last night, about this, and there's probably more efficient ways of doing this. But after playing with this for a little while, I just took op1 of evalf of 100 digits of pi, and I modded that by 10. And what that returns is that 100th digit. Right? So op1 is that without the decimal point. We just collapse that out. So it's an interesting way. If you want to go through here, we go, that's the 101st digit of pi and so on. But what I use explore for is here we have a parameter. Right? Here we have something we could say, well, show me the nth value of pi. Right? So what we now do is we say, okay, explore of op1, evalf n, all that messy stuff that I just talked about. And then let's look at for different values of n. So we'll start with n equals 1 to 10 to the power of 4. I'm going to be conservative and stick with 10,000. I heard that was how many we store. So here we can scroll through now, and there's the 10,000th. I like living risky, so let's try 100,000, or a million, sorry. This may break my Maple, but that's par for the course. Yeah, it certainly did. So I should probably have disabled the continual drag there, because I've probably just asked it for about half dozen values.
It's okay. We store about 30,000, I think. And then
Is it 30,000?
It will compute more, right? But then if it computes 100,000, it will also have all the intermediate ones.
Okay. Yeah. In any case, this is the type of thing I like to do with Explore. It's an explorational tool, for lack of a better term. Right? It's a lot of fun. We can actually play with the mathematics here.
There you go.
Oh, it did? Yeah, it came back eventually. Yeah. I think where Explore really starts to come to life, though, is when you start looking at visualizations. Right? So the math is fun, but visualizations are even more interesting to me. So here we have another system. We have plot 3D of sine of a times y times b times x squared. And I've kind of put a and b here in bold. Those are the two parameters we're looking at. And I've got some values that we've defined for x and y. And I'll just choose Explore from over here. And that now it says, OK, here are our options. And we can again go through here. And I'll make some slight alterations. Let's go 2 times pi. And we'll make this into a dial. So you do have options of your input controller here. We'll leave B as a slider. And we'll just choose Explore here. And drag these values out. And now we can see how the 2 parameters A and B affect this system. So Explore, it's building all for you, right? We're taking Explore, and it's now hooked up a slider with B, a gauge with A. We're able to visualize and see how this is changing for different values. So when I started, I talked a little bit about how I think about interactive documents as being kind of a natural evolution of Maple. I view Explore as probably one of the most important commands that have come around in a long time for Maple. You know, I wasn't kidding when I said it was plot 3D, probably animations of plots, and then Explore, because you take 2D, 3D, and then maybe you include time as another dimension. But now you have Explore, where you can add in as many parameters as you like and have controls over those things and just see how systems change. This was one I was working on over lunch. There was an example yesterday which involved tangent lines, I think. So you don't just have to explore a single plot. You can explore procedures as well. So here I wrote a quick procedure in Maple. It's a procedure with f, which is an input function, x, which just is a value on our x-axis. And what it returns is a plot of our function. It returns the tangent line. So we're doing a plot of student calculus 1 tangent based on our function, where x is the value that we're taking in here. So it's a value at that point. And then we're doing a point plot of where that point is. So keep my fingers crossed this works. And it did not execute that. Now it works. All right, so now we have a slider that lets us move along the curve. And what we have on the blue line here is our tangent line, red line, or the burgundy line here is our curve. The part that I did not get working entirely was the option here to actually have the ability to click. Now this is working, but I was going to make it look a little bit better. So you can click along the axis. You can click at points here and see the tangent line. So what I'm adding onto this one now is Explore, the command. I'm adding in something called markers. I can do interactive markers with Explore. So Explore, it's cool tech, right? Like it's taking what we have before, and it's just adding all these layers of interaction to it. And it's doing so with this one line of code. So we're not coding for hours. We're not trying to build something overly complex. We're just taking procedures or plots or Maple expressions, and we're looking at those values. I'll show you one other example with clickable controls. This one was really nice. This, by the way, is I don't see Dave in the audience, but all this is at Dave Linder's excellent work. So this is another one talking about markers. And here we have a command, plots display. And what we're doing is we're plotting a polygon. And in fact, we're just plotting a polygon with 3 points. So that is, survey says, a triangle. And if we use the explore command on this polygon, we can now have 6 parameters, if we count them, x1, y1, x2, y2, x3, y3. So what that is basically telling Explorer is that we want to explore interactively the corners of this triangle. And my computer is having fun now. This is usually pretty. This usually never has any issues.
It's still on pi.
It could be. This one is usually seamless. This one's never broken on me before, so the fractal example always breaks on me, so this one's interesting. All right, anyway, the point of the matter is that what Explorer gives us controls over is these corners, right? And it gives you interactive control. It uses these as markers. You can move those around and have an interactive triangle.
What is the option for dragging in Explorer? You get markers.
Markers, yeah. So
Can you lift stuff a little bit?
I wish I could. However, I'm going to take a temporary pause as I get Maple to come back to life. So I apologize for that.
No, it's fine.
All right, so I've actually only got 10 minutes left, so I'm going to jump through a couple of really quick ones, and do speak up if you do have questions along the way. There was a couple I really wanted to show. Let me skip over what I've been working on, because I want to show you this animation instead. Here we have an example where we're going to explore something coming from our fractals escape time package. This is a Mandelbrot fractal. We've got two parameters. One is our zoom level. The other one is our iteration limit A. And this is using the explore command. We've specified here all the parameter settings, so everything is automatically ported over to explore. So here we have parameter settings for A from 50 to 300, zoom from 0 to 8. And we add in some more options, like animate. So what animate does is it lets us do literally an animation. So the way it creates an animation is by doing a parameter sweep. So here we're actually sweeping through two parameters at the same time. Let me turn that off instead. And what we're going to do instead is we're going to leave zoom static, and we are going to sweep through A, the iteration limit. We're going to see that that's not very interesting. Let's instead look at zoom. OK, that's, of course, going to zoom that way. Let's switch back again and have a look at iteration limit with higher zoom. There we go. That's a little bit more interesting. So what I like about animations with Explore in this way is that this is where we can do a true parameter sweep, right? Where we can do stuff that we really can't do by hand, right? We're letting the computer do an animation for a single parameter while we have fixed values for another. So here we can, if we're looking at playing around a system, we can move around our zoom value, or you can imagine this as being any parameterized system. We can move these values around, and we can see how another parameter would influence that other parameter. So that's an animation. I'm going to show this one quick as well, because this is another one that it's on our Explore examples page, and it's just a beautiful example. This is something we don't have in Maple. It's a function for creating a Cobweb plot. It's again within fractals, so we're talking about iterative systems. And I'm going to load this up. I'm not going to explain it. I'm going to show you what this looks like at one stage. So this is this so-called Cobweb plot. And let me show you this being explored. And I'll play this one back. And this is an example where we're seeing chaotic behavior at a certain value for these parameters, R at least. So here we have R, we're animating over R. We can change our initial point x0. See how that changes the system. Here we have another value for n, which I think is the number of iterations. So it's just a great way of getting in there and kind of visualizing stuff. And in this case, if we go back up to the code, we're building new code here. We're visualizing our own code, our own procedures. So Explore doesn't really, it's not picky. Anything in the Maple language can be explored. So it can be, as we saw before, a mathematical expression. It can be a plot. It can be a procedure. It can be any one of our 6,000 commands. Right? So anything in Maple, you just have to pick what to explore, what's meaningful to look at. And that's kind of where you get into the most difficult part of all this, right? Is kind of what Doug was talking about at the end. Is we can generate all these explorations, and we can make some really cool looking stuff, but then trying to kind of take that and make sure that does actually have pedagogical value, that's the most difficult part. But playing around with Explore, this gives you a tool in your kit that is just absolutely invaluable. The example I don't have time to show today is an example of some of the work I was doing in cluster analysis. And I use Explore a lot of the times just to try to break commands. So the developers put together a new command. I'll use Explore to throw 1,000 different iterations of parameters at it and just see what happens. So what I'm going to say is there's more examples. You can find them on a help page on Maple called the Examples Explore page. It is a command itself, so you can read more about it, but that command page has a ton of really good stuff. I won't cover sharing today. I will just mention that we have a couple of examples also for building applications in Maple. So to talk about the stuff at the beginning of our talk, talking about actually creating applications from scratch where you're building applications by inserting embedded components. You could look at this application in Maple. It's called Building an Interactive Number Line. There's a YouTube video that walks through it as well. There's also another application called Building Applications with Explore. That's going to use Explore to actually build out an application that you can then add to by adding to the code of that application. So those would be two good resources I would recommend. They have videos. They have content inside of our Maple help system. There's lots of good stuff there. I'm going to end it there with 5 minutes. What I will say is if you do have any questions about this stuff, we are around still. I'm happy to answer questions even outside of this room if you're curious about it. There's a lot of good content, and I'm not kidding when I do say this is really important tech. And if you're not using Explore today or using some of this newer technology in your workflow, I would certainly just check it out, right? Just see if it fits. You know, if you're doing high-level research, there might even be an interest here for you because you could do, you know, I use it for data analysis, right, where you actually are plugging in values and you're not really sure what your model looks like, so you hit Explore. You hit it with Explore, and it basically lets you just explore how that visualization will change. So as I said, I'm going to leave it there. I want to make sure Steve's got some time to get started. So are there any questions about anything that I've talked about today?
What's next?
What's next? What's the next evolution?
Yeah.
Well, what are you
going to add to Explore now?
Whatever you want. Certainly form factor. You know, we have to make sure that where we deploy Explore to is supported, right? So if we talk about mobile technology, if we talk about online, if we talk the cloud, we have to make sure that whatever Explore can create, it can't just create it for Maple. It has to be creating applications that can be deployed elsewhere. So that would be certainly a big what's next for Maple, for Explore.
There are constraints. I mean, anything in the cloud can run on. I can access the cloud through a browser. Yep. Right.
Yep.
So it runs without having Maple.
Yep.
So there are limits on what. There are some things in Explore that wouldn't work with that.
There are. What I would say is if you do Explore applications where you have one input, one output, it's going to be perfect in the cloud or through a tablet. If you have, I've got an application where I had 185 checkboxes. That will not work well in the cloud, right? Because it just does not have enough screen real estate.
So it's not the cloud that's the problem.
It's a layout engine. So
yeah.
we actually have to look at the layout engine and say, okay, if we're building for mobile, what do you do, right? Do you kind of, okay, say if you have 180 checkboxes, do you collapse them into a collapsible table? Do you paginate? Do you kind of do things like that? So there's a lot of that type of consideration that we have to look into to make sure that whatever next evolution for Explore, whenever that happens, we have to make sure that that is supported. So, yeah. After that, there's lots of other bells and whistles we'd love to add to it.
Yeah, but actually, I'm going to argue Explore is awesome because from the student's standpoint, they can make the jump of, okay, it's just doing math and it's just putting different numbers in. It is interesting when, again, I survey the students, I say, well, here's this black box system of you move the scrollers and and to them, then that's just some sort of animation they get out of Disney and they don't see the connection. But that's the trickiest part. Thing. It's a sort of a connection thing. So in fact, I never went to Maplex, even though I saw the value, I saw what you did.
Yeah.
It's just it's amazing how just being able to say, okay, I see the math here, so I can see where you got to.
Yeah.
So
yeah.
The animate's just gonna work on.
Yeah. I like the plot component for that reason.
Right.
Because the plot component is a little more natural. Right. It's kind of the way that a student would approach it with a pen and paper.
I could do
like, you could draw a curve, and then, okay, that's being revolved around an axis. That's just something that the TI series is not going to give you.
No.
Yeah. So, sorry.
Just a little remark, because we are using these components in education. So even high school students, we train them how to prepare some components.
Yep.
And we prepare also some contextualized problems or similar things as what you show. And some students they become really good, right, in preparing this kind of stuff. Okay, when I do it on my own, usually I do really the old style. It's like preparing all my, let's say, components. I don't use Explorer so much, even if I knew it.
Yeah.
Now I think I will use it more because I see the potentialities.
Yeah.
But then really, just to mention that really even students can understand all of it.
Yeah.
So they could become very, very good. And so that's all the educators here. I say, use them because they're very good with students.
Yeah.
I mean, I would say that for me, the hardest part about making my own interactive resources is figuring out how I want to do the layout. And that's something that Explore, I mean, I'm thinking now, could I use Explore, or should I use Explore to get the basic layout and then polish it from there or something?
Yeah, I think that's where we spent some time working, is making sure that the base layout is the one that is the easiest to work with. But you're right. I mean, if you look at some of those other applications that we were showing there, you almost have to be a UI developer or UX developer in order to get kind of a proper workflow for a student, right? Because even if you talk about the application you showed before, having to have a flow through an application just so a student knows where they're going, we add in tool tips, we add in glowing buttons or highlighting or whatever we can just to kind of drive interaction models, right? But it's not easy. But if you can kind of reduce it down to something very simple, then it's easy. But once you get into multi-step, once you get into interaction models where there's a lot involved, it takes time. Mm-hmm. Yeah. So okay, I need to wrap up. So thanks everyone for listening.